What's up, everybody? It's Miss Brothers. Hey, we are working on our last practice. This is the thermal energy practice 1, and this is going to be the last practice for Q problems before our test, which is going to be on Friday. So I'm just going to go through page 1 in this video, and then I will go through page 2 in a second video. Just a couple of things to remember as you're doing these problems. You want to make sure that you have your specific heat triangle with you. Again, our trusty specific heat triangle, this thing right here. You will have one of these available to you when you take the test on Friday, so just know that that is something that you will have. The other thing I want to point out is that you've got this table at the top which shows you different specific heats of substances. And just know that you'll have some problems like this on the test, and you'll definitely have a table like this, so you need to know what you're looking at. So we're just going to go through each of these problems using the process. Again, this is that process that I taught you, last week, and it's on slide 35 of the Unit 2 notebook that's posted every day on Google Classroom, and I move it into the daily topics each day so that it's there every single day. All right, so again, you guys, as we are looking at our first problem, it says how much energy must be transferred as heat to 125 grams of water in a pan in order to raise the water's temperature from 25.4 degrees Celsius to 37.4 degrees Celsius. Again, the first step of the process is that we need to know what is it we're trying to find. And we look for words like how or what or why. In this case, we're going to go with how much energy. So that's the first one. So the things that we could be looking for when we are using this equation, we could be looking for energy, which is Q. We could be looking for mass, which is M. We could be looking for the change in temperature, which is delta T. Or we could be looking for C, or CP, which is the specific heat. In this case, we're looking for energy, so we know that we are looking for Q. So Q equals something. Going back to our specific heat triangle, or our Q triangle, we're trying to find Q, so that's what we're going to cover up. And what's left is mass times the change in temperature times the specific heat. So we know that's what we're going to be looking for, so we know that Q equals mass times the change in temperature times the specific heat. And again, I use CP as specific heat in my classroom because I think it sort of mitigates confusion when it comes to using C for degrees Celsius. Now, our next order of business is that we have to go through and figure out, do we have every number we need in order to fill in this equation? So let's see. Do we have the mass? Yep, here it is, 125 grams. Do we have the specific heat, which is right here? Well, it's not listed in the problem at all, but it is up here in this table. And specifically, it says right here we're dealing with water. So I know that I'm going to be looking for water. There's the specific heat right there, 4.18 joules over grams degrees Celsius. So I don't have my change in temperature yet, but I do have enough data where I can find my change in temperature, and I'm going to do that by using this formula. Change in temperature equals my final temperature, TF, minus my initial or starting temperature, known as TI. So that means I have to go into my problem and I have to figure out where it is. So if I underline that, I know that my temperature started from 25.4 degrees Celsius, and it went to or ended at 37.4 degrees Celsius. So my TF is going to be 37.4 degrees Celsius minus my TI, which is 25.4 degrees Celsius. So my change in temperature, if I do the math, equals 12.0 degrees Celsius. So now that I have that change in temperature, I have all the numbers that I need in order to complete this calculation. So my Q then will be equal to 125 grams times 12.0 degrees Celsius times the specific heat of water, which is 4.18 joules over grams degrees Celsius. So now I can just bust out my trusty calculator and I can do the math on that. And if I do the math, I've got 125 times 12.0 times 4.18 equals 6,000. So my Q equals 6,270 joules. Now, I know it's joules because of two reasons. A, I know that the unit for Q is J, or joules. But also, if I don't know the unit, I can go through algebraically and cross out all of these other units. I can cross out grams, degrees Celsius cancels out right here and here, so the only unit I have left is joules right there, and that's what ends up in my final answer. And notice, you guys, how I circled my final answer, and that's what I want you to do whenever you do a problem in my class. Please circle the final answer, because that way I know, if you look at this, there's a lot going on in this problem. That can be really confusing, especially if I'm trying to grade it. It can also be confusing for you. Once you get that final answer and you're happy with it, go ahead and circle it, and that's where I'm going to put my first look. I'm going to check your answer first, and then I'm going to look at your process. And I'm going to be looking for lots of little things. I'm going to be looking, did you write me the formula? That's a point. I'm going to be looking, did you include the units throughout the entire problem? That's a point. I'm going to be looking to see if your answer is correct and if you included that final unit. So, like I said, if you're going through your process and if you're doing these things, you're scoring points all the way. Okay? It's not just about the answer. It's also about the process. All right, let's do number 2. How much energy must be transferred as heat to 375 grams of water in a pan in order to raise the water's temperature from 25.4 degrees Celsius to 37.4 degrees Celsius? Well, those numbers look familiar. I'm going to go ahead and underline those. Again, I'm looking for how much energy. So I know, again, same as my previous problem, that I'm looking for Q. And I know that Q, based on what I did before, is mass times the change in temperature times the specific heat. Do I know my change in temperature? Well, actually, I kind of do. Yes, I could go through the TF minus TI. But if you look, you guys, the change in temperature is the same here as it was in the previous problem. And in the previous problem, it was 12.0 degrees Celsius. So I'm just going to use that data from the previous problem because that's me being efficient. And now I can go ahead and look at the same information. I'm still dealing with water. This time, though, I'm dealing with 375 grams of water instead of 125 grams of water. So let's go ahead and solve for this. So Q equals mass, which is 375 grams, times 12.0 degrees Celsius, times, again, we are dealing with water, so the specific heat of water is 4.18 joules over grams degrees Celsius, because that's that fun unit for specific heat. And now, I can just go ahead and plug that in. 375 times 12.0 times 4.18 equals 18,810 joules. And again, same rules apply. I know that joules is the unit for Q, and I can also go through again and just cancel out my units for grams and cancel out my units for degrees Celsius, and the only one left there is joules. So now, if we look at question 3 relates to what we did in questions 1 and 2. Question 3 says, explain why the answers to question 1 and 2 are different. Well, the first thing we have to look for is what's different. We know that these two questions had the same change in temperature. They had the same substance, which again has the same specific heat. What was different is that we had 125 grams of substance here and 375 grams of our substance water right there. So these answers are different. They are different because they have different masses. Because they have different masses. And so what that means for our problem is this. If you look, if we have more mass, it means it requires more energy to heat that water. Yes, water has the same specific heat. In other words, it takes 4.18 joules of energy to heat 1 gram of water 1 degree Celsius. However, it's going to take a lot more energy if we have a lot more mass. So just understand that mass can affect how much energy needs to go into any system. If there's more of it, it takes more energy. Okay? All right, let's do question 4. A 32-gram silver spoon warms from 19.8 degrees Celsius to 75 degrees Celsius. So what is the change in thermal energy? So again, you guys, the question is, we're going through our process. What is the change in thermal energy? So again, what we are trying to find, we're trying to find energy. And if you know your stuff, you know that energy means we, again, are trying to find Q. And again, if we go back to our specific heat triangle and cover up Q, it's mass times change in temperature times specific heat. So let's do that. Writing my formula, because that's part of our process. times change in temperature times specific heat. Let's see what we have. Because again, that's our next step. We have to go through and figure out what needs to be found in this formula. Do we have mass? Here it is right here. Do we have change in temperature? We don't, but we have the temperature data that we need to calculate it. And do we have specific heat? We do, because we know this is silver, and silver is right here on our chart, and it has a specific heat of 0.235. So now we have to go ahead and figure out our change in temperature. Let's take a minute to do that. And again, our TF minus TI, so let's figure out which is which. So it warms from 19.8 degrees Celsius. That's another way of saying TI to our final temperature of 75 degrees. So we're going to go TF, which is going to be 75 degrees Celsius, minus our TI, 19.8 degrees Celsius. So my change in temperature, if I ring that up real quick, 75 minus 19.8 is 55.2 degrees Celsius. So now I have everything I need to solve for Q. I've got my mass, which is 32 grams, and I'm going to multiply that by 55.2 degrees Celsius, which is my change in temperature. And I'm going to multiply that by my specific heat, which for silver is, again, 0.235 joules over grams degrees Celsius, because, again, that's the unit that I'm going to be using right there. So now it's just a matter of finishing. So my Q is going to be equal. So I'm taking 32 times 55.2 times 0.235 equals 415.10, and it's going to be joules because, again, we're trying to find energy. I'm going to circle that final answer. And again, the unit joules, because that's the unit for energy, or Q. And again, we could also go through and cancel grams and cancel degrees Celsius. And now we've got our final answer. So let's do the same thing here for question 5. And again, question 5 kind of works like questions 1 and 2 did. I have a lot of similar information. Let's read through this. A 32-gram aluminum spoon warms from 19.8 degrees Celsius to 75 degrees Celsius. What is the change in thermal energy? So I know I'm trying to find the change in thermal energy again. And look, you guys, I'm dealing with the same mass that I did in this question, question 4. I'm dealing with the same change in temperature that I did in question 4. But let's look at what's different. What's different is that I have silver in question 4, and in question 5, I have aluminum. So let's tuck that away in the back of our heads, because I have a feeling it's going to come in handy a little bit later. So let's go ahead and set this up. We want to find the change in thermal energy. So look, thermal energy, which means Q, again, and Q equals mass times the change in temperature times specific heat. The good news, you guys, is because we did most of this already in the previous problem, we know that the change in temperature is going to be 55.2 because we figured it out in the last problem. So we pretty much have everything we need to set up our Q problem. So let's do that. My Q equals my mass, which is 32 grams, times my change in temperature, which is 55.2 degrees Celsius, times my specific heat. Now remember, the specific heat is going to be different in this problem than it was in the last problem. In the last problem, we were using the specific heat of silver, which was 0.235. In this problem, we're going to be using the specific heat of aluminum. Here's aluminum, and it's 0.897. So when I fill this in, 32 times 55.2 times 0.897 joules over grams degrees Celsius. So now let's calculate using this new specific heat. So again, 32 times 55.2 degrees Celsius times 0.897 equals, oops, I think I did that math wrong. I'm going to do that math again one more time. 32 times 55.2 times 0.897, that's better, equals 1,584.5, I'm rounding up there, joules. And again, using joules because that is the unit for Q, and again, I can go through and I can also cross out, canceling the grams, canceling degrees Celsius. So the reason that we did this problem is that as we move to the next page, and like I said, the next video we'll go through page 2, is that we are going to talk a little bit about the differences between silver and aluminum and why these two answers are different because of those different specific heats. Alright, so that finishes up the video for page 1. If you'd like to continue and look at how I did page 2, you'll just need to check out the next video. Alright.